This video will describe the process of project crashing. Project crashing is spending extra resources to reduce the completion time of a project. In this example, there is a project with 7 activities, and the project network diagram is shown on the sheet. In the information provided, there's a normal completion time in weeks, and there's a crash time in weeks. The crash time is the minimum time that each of the activities can take. This means that there are some maximum number of weeks that each of the activities can be completed in. We can calculate this by taking the normal time minus the crash time. In this example, the costs listed are interpreted this way. The normal cost is the total time to complete that activity in the number of weeks listed in the normal time column. The crash cost is the total time to complete the activity within the number of weeks listed in the crash time column. It's possible for that activities that have a max crash of more than 1 week can be crashed for less than the maximum. So we need to calculate the crash cost per week. This is the crash cost minus the normal cost divided by the maximum number of weeks the activity can be crashed. The error for activity C is because it cannot be crashed, so I'll just put a large number there, which will force our solution away from that activity. The column crash is the number of weeks that we're going to pay the extra crash cost to reduce the time of the activity. This means that the total crash costs for the entire project are the sum product of the crash cost per week and the number of weeks we crash. The realized time is the actual time it's going to take to complete each activity after we consider the fact we might be crashing it. It's the normal time minus the number of weeks crashed. Now we need to use the usual rules to come up with the early start, early finish, late start, late finish, and slack times. When we do this, we're going to consider the realized time so that our calculations will adjust should we choose to crash some of the activities. For early start, the early start for the 3 activities with no predecessors is 0. The early finish time is the early start time plus the realized time. I will go ahead and copy this to all of the activities. The early start for D is the early finish for A because A is the predecessor of D. The early start for E is the early finish for B because B is the predecessor of E. The early start for F is the early finish for C because C is the predecessor of F. The early start for G is the maximum of the early finish times for D and E because they are both predecessors of G. In this project, we have 2 activities that have no successors. These are the completion activities. The late finish time for these, which are G and F, is the maximum of the early finish time for all the activities. I'm using the absolute references on the columns and rows within the max formula so that it can be copied to activity F. For any activity, the late start is the late finish minus the realized time. The negative numbers will correct when we go backwards through the diagram and consider the predecessor-successor relationships. If we look at activity E, it has one successor, which is G, so the late finish for E is the late start for G. D has one successor, which is G. The late finish for D is the late start for G. C has one successor, which is F, so the late finish for C is the late start for F. B has one successor, that's E. The late finish for B is the late start for E. A has one successor, that's D. The late finish for A is the late start for D. Now we need to calculate the slack time, which is the late finish minus the early finish. Activities with zero slack will be on the critical path. I'm going to enter an if formula that will tell us which activities are on a critical path. If the slack is equal to 0, then we'll use a 1 to indicate an activity is on the critical path, or 0 otherwise. What we can see is that A, D, and G are on the critical path. Now that we've determined the critical path, we want to know how we should crash this project if we want to get the completion time down to 10 weeks. Right now the completion time is 14 weeks because we can see that that's the largest, latest finish time in the project. I'm going to copy this to a different tab. And in this tab, we're going to consider crashing the project to 13 weeks. We need to consider which combination of activities we can crash, the cost, and whether or not the activity is available to be crashed. We need to crash one activity from each critical path. In this case, there's just one critical path, so we need to crash A, D, or G. We look at the max crash. Each of them can be crashed by at least 1 week. The cost to crash A is $600 per week. The cost to crash D is $75 per week. And the cost to crash G is $250 per week. So we choose the activity that has the least cost. The conclusion is that we want to crash D. So we enter a 1 in the number of weeks crashed for activity D, and we can see that we're down to 13 weeks. So we're going to repeat this process. We now want to consider crashing down to 12 weeks. We see that the critical activities are the same. Activities A, D, and G are still on the only critical path. A can still be crashed, D can still be crashed, although we've used 1 week, we've still got 3 available, and G can still be crashed. D is the lowest cost, so again the conclusion is to crash D. After we crash D, for a second week, we see that the critical activities have changed. In fact, B is now a critical activity. E is now a critical activity. And A, D, and G are still critical. This means there are 2 critical paths, A, D, G, B, E, G. So when we crash down to 11 weeks, we're going to need to consider both paths. Now we need to crash one activity on each path, and there are many combinations of ways to do this. For instance, we can crash A and B, one on each path. A and E, D and B, D and E, or simply G, because G is on both paths. A and B are each available to be crashed by 1 week. A and E are each available to be crashed by at least 1 week. D and B are available to be crashed by at least 1 week. D can be crashed 2 more times. D and E are available, and G is available. To find the cost for crashing these combinations of activities, we need to consider the cost for both activities. The combination of A and B would cost $1,300. The combination of A and E, $650. Combination of B and D, $775. The combination of D and E, $125. And G costs $250. Since we need to crash one activity on each critical path, the combination of activities that's the lowest cost is D and E. So we'll crash D by an additional day and E by 1 day. We can see that critical activities are still A, B, D, E, and G. We've now crashed the project down to 11 days because that's the maximum latest finish time. Now we want to examine crashing the project down to 10 weeks. We need to crash again one activity on each critical path. The combination of A and B is available to be crashed. Each has a max crash of 1. Neither of them have been crashed previously. A and E is similar. A is available to crash. E has been crashed by 1 week, but there's 2 additional weeks available. D and B are available. D has been crashed by 3 weeks, but there's 1 additional week available, and B has not been crashed. D and E each have at least 1 crash day available, and G has 2 crash days available. So again, if we're going to go down to 10 weeks, the best solution is to crash D and E. We do that and we see that the project's now going to be completed in 10 weeks. Now we have the question asked as to how we could crash the project down to 7 weeks, but we're going to move 1 week at a time. So we'll start by crashing to 9 weeks. What we see is that there are still 2 critical paths, but that there are no crash days left available for D. So this eliminates all the combinations that one activity on each critical path that involved D from consideration. So clearly now our best solution is to crash G. This gets the project down to 9 weeks. Now we go to 8 weeks. A and B are still available to be crashed. A and E are still available to be crashed. E has 1 week left. We've crashed it by 2 weeks. There were 3 available. G has 1 week left to be crashed. We've crashed it by 1 week, but there were 2 available. So again, the solution, the lowest cost solution, is to crash G by an additional week. And now we're down to 8 weeks, excuse me. So finally, we'll crash to 7 weeks. We notice that we've now hit the maximum for G. G is no longer available to be crashed. There are still 2 critical paths. The only combinations left then are AB and AE. AE is the lowest cost. So we crash A by 1 week and E by 1 week. We've crashed the project down to 7 weeks at a cost of $1,550. What if we wanted to go down to 6 weeks? What we notice is that E is no longer available. We've crashed it by 3 weeks, where its max was 3. A is no longer available. But there's still 2 critical paths, ADG, BEG. This means that there's no combination of activities, one on each critical path, that can be crashed to bring the project down to 6 weeks. So the minimum project time is 7 weeks. So on the previous panel, this is the project crashing plan that will achieve our goal of 7 weeks.